Hello, I'm going to review some formula units and constant in mechanics. The first one, Newton's second law. Net force, Fn, N stands for net, equal to ma. Unit for F, force, is Newton. For mass, is kilogram. For A, is meter per second squared. Second one, Newton's first law. Net force is equal to 0. So your acceleration will be 0. So if you're rest, you will stay rest. If you are moving in a straight line, you will continue moving in a straight line with the same velocity. Number 3, universal gravitational law. So Fg is the gravitational force. G stands for gravitational. G is the universal gravitational constant. M1, M2 are the two masses. So Fg exists between any two masses with the distance are separated. So F is Newton. G unit is Newton meter squared divided by kg squared. M1, M2 is kg squared. R squared unit is meter squared. Number 4, gravitational potential energy. In the local case, when G is constant, PE is short for potential energy. U is short for PE. Is equal to mgh. M is the mass, G is the local gravitational acceleration, h is the height with respect to the reference that you've chosen. So G is typically 10. U is a unit of energy, joule. M is kilogram. G is acceleration units, meter per second square. H is in meter. Number 5, gravitational potential energy in a global case. So when G, the gravitational acceleration may not be constant. So U is equal to minus G M1, M2 divided by R. R is the separation between M1 and M2. G is the constant 6.67 times 10 to the negative 11, which is the universal gravitational constant. U is in joule, G is in this unit here, M1, M2 is kilogram square, R is in meter. Number 6, kinetic energy. It's the energy of motion, short as K, also short as KE, equal to 1/2 mv squared. M is the mass, V is the velocity. So since it's a square, it's always positive. So K is always positive as it defined. So as KE is one of the energy unit is joule, M is in kg, V is meter per second, so square is meter square per second square. Spring potential energy, so the energy stored inside a spring that has been compressed or expanded, either way. So that's equal to U potential energy with the S short for spring, 1/2 kx squared. K is the spring constant, X is the displacement, or the compression, or the expansion, depends on the situation. Units for energy is joule, K unit, spring constant, it's Newton per meter. X is in meter, so meter square. Number 8, Hooke's law. Hooke's law, spring force, S stands for spring, it's equal to spring constant times the displacement. So it can be compression or expansion. Yeah. Normally there's a negative sign, but here we just ignore it. So Fs is force, so that's Newton. K is Newton per meter, displacements in meter. So those are some of the unit. We continue to number 9, centripetal acceleration. C stands for centripetal. It's equal to V squared divided by R. V is the linear speed, R is the radius of the UCM. UCM stands for uniform circular motion. AC, unit is acceleration, meter per second square. V is meter per second square, so meter square per second square, divided by R. R is in meter. 10, centripetal force. C stands for centripetal. So centripetal force can also be called radial force. It only means the force in the radial direction that point to the center of a circle. So Newton's second law can be applied. Fc is equal to mac. Unit is Newton. Mass is in kg. AC is meter per second square. 11, gravitational acceleration, small g, is equal to gm. M is the planet that has this gravitational acceleration, r squared. So G unit is meter per second square. Capital G is the universal gravitational constant. The unit is Newton meter squared divided by kg squared. M is mass, is in kg. R squared is meter squared. 12, conservation of mechanical energy. So mechanical energy is constant. So mechanical energy in the 1 situation or initial is equal to mechanical energy at 2 situation or mechanical energy at final. So potential energy 1 plus kinetic energy 1, it's equal to potential energy 2 plus kinetic energy 2. So this 2 together is ME1. This two together is ME2. The unit is joule and joule. Number 13, work energy principle. N stands for net. So net work. So W is work. Net work is equal to the change of kinetic energy. Joule and joule. Number 14, extended work energy principle. So sometimes the non-conservative force does work. The most obvious example or notable example is the work done by friction. The other non-conservative forces usually does not do any work. So only the friction comes up most often. Work by non-conservative forces is equal to the delta ME. And delta ME is equal to delta KE plus delta PE. Number 15, work by conservative force, the WC. C stands for conservative. So conservative forces, examples are gravitational force, electric force, spring force. So the work done by this type of conservative force will be equal to the negative of the potential energy change. Number 16, static friction. Static friction is a less than an equal sign. So it can be 0, but the maximum will be this value here. So mu s is the static friction coefficient. It has no units. So you have Newton here, you have Newton here, and this one has no units. So that's the review of mechanics up to now.